Welcome to your third lesson in this unit. In this lesson, we're going to be adjusting expressions into proper scientific notation. This expression written below is not in proper scientific notation. When you look at the first coefficient, 51 and 6/10, it is not a number between 1 and 10. So what we have to do is adjust our first coefficient. But when we do that, our exponent must also be adjusted. You might be thinking to yourself now, Miss Lupe, I'm not going to listen to this lesson because what I'm going to do is use my great scientific notation skills and not write it incorrectly to start with. But I wouldn't be doing this lesson for no reason. When we start learning shortcuts and adding and subtracting scientific notation, we will get originally our answers like this, and we will have to use this lesson to help us move our answers to proper scientific notation. So thank you for listening. So what will we do first is solve this problem. We know 10 to the third power means 10 multiplied by itself 3 times, which equals 1,000. When we multiply that by the beginning coefficient, we get the following solution. Let's see how we can use this solution to help us move our answer into proper scientific notation. Before continuing with this problem, let's talk about a few things we know. We know that this beginning expression is going to be equivalent to the expression in scientific notation because our objective isn't to change the value. We actually want to keep the same value. All we're doing is writing it in proper notation. So, we know this beginning expression also equals 51,600. We can conclude, because the beginning expression is equal to the expression in scientific notation, that the form in scientific notation will also equal 51,600. Now let's begin to write our expression in scientific notation. We know in scientific notation the first coefficient must be a number between 1 and 10. So when we move our decimal here to make a value of 5 and 1600ths, it is in fact a number between 1 and 10. Our next step is to write it being multiplied by a base 10. The only information we don't know is this top exponent. One of your lesson checks today is to have a conversation within your community of strategies you could come up with to solve for this unknown exponent. I would like for you to record at least 2 different ideas or strategies that you could come up with before moving on. So right now, please pause the video. I hope you had valuable conversations within your community. Now I'm going to share with you some ideas I've heard students use in the past. Once I heard, well, I know I'm trying to get the scientific notation. The exponent tells me how many times to move, and I'm trying to get this final solution. So the student told me what they did is they looked in their brain, and this is what their brain looks like, in their little thought bubble. They wrote the final solution, 51,600. If the decimal starts here, how many times would they have to move it to get it to the proper spot? 1, 2, 3, 4. Because they moved the decimal 4 times, they know the exponent is 4. Put yourself a star if you thought the same way as that student. I've also heard it explained comparing multiplication problems. So I had a student look at the first expression and put it in expanded form. When written in expanded form, it is 51 6/10 times 1,000. The student then told me that they knew these were equivalent. And then they wrote down the first coefficient on this side. They told me because these two values had to be equivalent, and this is 51 and some change, and this one is 5 and some change. 5 is a whole lot smaller than 51. So because 51 is being multiplied by 1,000, 5 and some change needs to be multiplied by a number greater. They knew the value had to be a base of 10. So what they did was they started adding zeros. Because 1,000 was too small, they added one more zero and tried 10,000. When you put this in your calculator, 5 6/100 times 10,000, you do get the proper answer. Put a star for yourself if you thought the same way as this student. Those were some great strategies on finding the missing exponent. The Common Core really values your way of thinking. Another thing the Common Core really values is efficiency in our work. And for you, that means working as little as possible to get as much as you need done. So to be as efficient as we can in this problem, we want to create a rule for ourselves to make it very simple. So I'm going to look in very close. I'm going to examine that what I did for the beginning exponent was I moved it to the left. So I'm going to make that note. I also noticed my exponent moved from 3 to 4. So my exponent went up. And it went up the amount of times I moved my decimal left. So I'm going to make that note for myself. I wonder if this is a rule I could use on other problems. Let me test it. Based on our observations on our previous problem, we made up this rule. When the decimal moves left, we increase the exponent, and also the exponent is increased by the number of times we move the decimal. So let's prove that rule with this example. To write this in scientific notation, we have to move the decimal into a location to make the number between 1 and 10. So I'm going to move the decimal right here between 1 and 9. So it would look like this. Now 1 and 92/100 must be multiplied by a base 10. But what is my exponent? Based on my rule, I would have to increase my exponent. So originally my exponent right here, 2, must be increased by the number of times I moved my decimal left. And I moved it 2 times. So I'm going to add 2. 2 plus 2 is 4. So I can conclude that my new exponent is 4. To double check that I did not change the value, I put both of my equations into my calculator and my value did not change. So yes, my notation in proper scientific notation is 1 and 92/100 times 10 to the 4th power. So now let's use this rule when our exponent is negative. Let's start adjusting this in scientific notation. When we move our decimal, we'll get it to look like this. We're also going to multiply that by a base 10. We're trying to figure out our exponent now. Our original exponent was -5. We have to increase that by the amount of times we moved our decimal. We moved our decimal 2 times. So to solve for our new exponent, it's going to be -5 plus 2. -5 plus 2 equals -3. So my new exponent is -3. I follow those same rules for moving my exponent left by increasing, or moving my decimal left. I then had to increase my exponent. Your final lesson check for this lesson is to write this expression in proper scientific notation and prove that you got the right answer. You would prove that you got the right answer by making an equivalent between these two. When your community has finished that, please turn that into your teacher and receive your classwork for today. Thank you.